Hello and welcome back to my channel. Students, from today we are starting a very important topic, stereoisomerism, in our problem series. We are going to take up problems based on stereoisomerism. We will start with the fundamentals, the basics first. Before we have answered the problem finally, we will cover all the fundamentals, concept behind that problem, and in this manner we are going to learn. So now let us try to see first what is there in question number 27. In question number 27, students, you can see we have 4 compounds on our screen, and I have mentioned the bond line diagram of those compounds. You have to mark and count the number of chiral carbons present in each of these compounds, and finally you have to sum up all the chiral carbons present in all of these 4 compounds. So first of all, to answer this question, we will understand the basic fundamental theory. What is the meaning of chiral carbon? How we recognize a carbon is chiral or not? What are the synonyms we use for the chiral carbon? What are the other names we use for the chiral carbon? And so on. So let us first see the fundamentals. As you all can see on your screen, first I have tried to explain what is the meaning of chiral carbon, or you may also call it as chiral center. Now, for a chiral carbon, you must have a carbon whose all the 4 valencies, all the 4 bonded groups must be different. For an example, if you see this carbon, it is tetravalent, it is satisfied by 4 groups. All the 4 groups, you should understand, are different. This is methyl, this is hydrogen, this is chlorine, and this is bromine. So for a carbon to be called as chiral carbon or chiral center, all the 4 bonds associated with that carbon must be different. You understand? All must be different. And the names you will come across for such carbon are many. Like, you can call such carbon as chiral carbon, or chiral center, or asymmetric carbon, or asymmetric center, or stereo center, stereogenic carbon, stereogenic center. So all these are the names which are used synonymously in our textbooks. So you should know all these names which we can use for a chiral carbon or a chiral center. Now, a few more examples we are going to take up. As you see in these 2 examples, again, if you see this carbon is chiral. Why? Because all the 4 groups, all the 4 bonds, you understand, this is a phenyl group, bromine group, chlorine, and cyclopropyl group. So you can understand all the 4 are different. So this carbon must be chiral in nature. Similarly, if you see this carbon, all the 4 bonds are different. Here hydrogen, here deuterium, ethyl, and chlorine. You should understand from this example that hydrogen and deuterium are same element, hydrogen, but are isotopes. So isotopes are also considered as different groups. Again, isotopes are considered as different groups. So hydrogen, deuterium, both are hydrogen element, but since they are isotopes, different isotopes, we will consider them as different groups. Now, we will start with the compound A and we'll try to find whether it has a chiral carbon or not. And how we are going to see that? By recognizing that any carbon with 4 different groups connected around it is going to be a chiral carbon. So once you see this bond line diagram, I have tried to include the hydrogens also, because all the carbon are tetravalent, all are making 4 bonds. So for an example, you see this carbon. So 3 bonds are shown, 1, 2, 3, and you know that all the carbon are making 4 bonds. So in bond line diagram, to complete the 4 bonds, the missing must be satisfied by hydrogen. So 3 are already there, 1 is missing, so you should complete it with 1 hydrogen. And all the terminals are, you should understand, CH3, because carbon is there, 1 bond is already there, so each carbon makes 4 bond. If it is saturated, 1 bond is already there, so 3 must be satisfied by 3 hydrogen, and therefore it becomes CH3. Similarly, we will do with all the terminal carbons, and as you can see in your picture, all the terminal carbon I have put CH3, and wherever there were 3 bonds or 2 bonds, I have completed the 4 bonds by putting hydrogens, extra hydrogens. So now you can see all the carbons are having the 4 bonds. Now we will recognize the carbon having all 4 different groups as chiral carbon. So once you see, for an example, this particular carbon, you find that this particular carbon is not chiral carbon. Why? Because it has two same group. Here also it is attached with methyl, and here also it is attached with methyl. So it's not chiral in nature. Now coming on to this carbon, you understand, with this carbon, let us try to see all the groups attached. So let me make it clear. So you understand, one group is this is isopropyl group. You can understand this is one group. This is another group, methyl. This is another group, hydrogen, and this is another group, ethyl. So you understand, all the 4 groups are different. One is methyl, one is hydrogen, one is ethyl, and one is isopropyl. So all the 4 groups are different. So we will call this carbon as chiral carbon or chiral center or stereo center or stereogenic carbon, etc. Now coming on to this carbon, you understand, again this carbon is not chiral, because you see immediately that there are 2 same groups hydrogen associated with this carbon, so it cannot be chiral in nature. Similarly, you can see CH3, 3 are same group, here CH3, here CH3. So altogether if you count, you get just 1 chiral carbon in this compound. So here we have obtained number of chiral carbon as 1. Now we will see in compound number B. In compound number B, again, as you can see, we have a bond line diagram, and I will ensure that all carbons are now making 4 bonds, because then only we are going to compare it easily. Okay, so the same thing I have expressed in a more elaborate manner. Now if you try to understand, if I start with this carbon, you understand the 3 hydrogen, again same group came, it cannot be chiral, it cannot be chiral. Now coming on to this carbon, you understand, here 1 methyl group, again methyl group came associated with same carbon, same groups, it cannot be chiral. Now coming on to this carbon, student, you understand, here you have a different group, here you have a different hydrogen, here you have methyl, a different group, and this right hand side a completely different group. So you understand, this particular carbon is associated with 4 different groups, and it should be chiral in nature. So you have got this carbon as chiral. Now coming on to the next one on the right hand side, again you see with this carbon, this is methyl, this is hydrogen, this is a complete, so let me make it more clear. So we have already discussed this is chiral. Now coming on to this is a different group, this is a different group, this is hydrogen, and this is a different group. So all the four groups associated with this carbon are different. So again, this is going to be a chiral carbon. Okay. Similarly, you can find that this carbon, again, all the four groups, if you try to see, let me make it more clear. This is a completely different group. This is a completely different group. You can count the number of carbons to ensure that the groups are different. For an example, this has 1, 2, 3, 4, 5, 6, 7 carbon. This has 1, 2, 3, 4 carbon. So 7 carbon group and 4 carbon group cannot be same. Similarly, the hydrogen is different and this is methyl group. So all the four groups associated with this carbon are different. So again, it's going to be a chiral carbon. Now coming on to this carbon, in a similar manner, you find that, let me make it clear, this is a different group, this is ethyl a different group, this is methyl a different group, this is hydrogen a different group. So all the four groups are different. So in this manner you have come to a conclusion that this compound had 4 chiral carbons. It has 4 chiral carbons. Okay, so this is how we are going to judge whether the carbons are chiral or not. Now let us come to the compound number C. Again, you have a bond line diagram. It's a cyclic compound in front of you. This bond line diagram, I have expanded it a bit to get a clear view. Now I am going to see whether the carbons are chiral or not. Once you see this carbon, you understand it is associated one side by methyl, next hydrogen, these two are different. Now you understand these two, the remaining two groups are joined with each other because it's a part of ring. Now for this to be, you judge whether these two groups are same or different, because now we have to compare this group with this group. For that to happen, you should now take a walk. You should now take a walk. For an example, you have to take a walk in this direction, that is anti-clockwise, and you keep on noticing which groups are coming in your path, in your way. Similarly, you start walking in the clockwise direction and take notice of all the things happening on your way. If you take the walk anti-clockwise, clockwise, and while noticing the groups you come across, you find that both the walks are different in terms of groups you encountered, then those two groups, those two paths are different paths, and you should treat both the paths as two different groups. However, if while walking anti-clockwise and clockwise, if you find that the environment you find are exactly same, then those two paths should be taken as, must be taken as same groups. Okay, so then it cannot be a chiral carbon. Now once you try to do this, for an example, then you so I will take this diagram for that purpose. So this carbon was under investigation. So there is one hydrogen, there is one methyl, and now you started taking a walk this way and you started taking walk this way. So you understand, once you are moving this way, there is one carbon, here you see the carbon, this carbon is 2 degree, this carbon is 2 degree, this is also 2 degree, and here you come, as soon as you come here, this is a 3 degree carbon. So here anti-clockwise direction, once you move, after 2 degree you got 1 3 degree. Once you were moving in the clockwise manner, you first got a 2 degree, and in the second position you got 3 degree. So in the anti-clockwise, the second position you got 2 degree carbon. In the clockwise, the second position you got 3 degree carbon. So in that sense, both path, both ways are not same. Both are different in nature, environment. So you should take these two as different groups. So again I am going to explain this, you understand. Once you have to decide about the groups, you should start taking the routes, anti-clockwise and clockwise. Once you start anti-clockwise, you get a carbon, this is 2 degree. You start clockwise, you get a 2 degree. So here there is a compromise. Then again you find a 2 degree carbon anti-clockwise. Here once you move clockwise, you meet a carbon that is a 3 degree. So you have taken 2 steps anti-clockwise, 2 steps clockwise. The second step you took created a difference. In the second step, anti-clockwise you got a secondary carbon, whereas once you were traveling in the clockwise direction, the second step you encountered is a 3 degree carbon. So there itself you get a important point of difference, and therefore you can say that the anti-clockwise route and the clockwise route are not same but different. So it had hydrogen as different group, methyl as different group, and these two are also different group. So now you can say that this particular carbon is chiral in nature, and in a similar manner you have done for this, you can do for the others also. For an example, if you try to see, let me make it more clear. If I want to see about this carbon, once you see about this carbon, you find that it is attached with 2 hydrogen. Again you find that these two are same, so it cannot be chiral in nature. Once you come to this carbon, again you find that hydrogen is different from methyl, and now in order to judge whether these two are same or different group, you have to do the same thing. You have to start walking clockwise and anti-clockwise. So I will do in this picture. So here hydrogen is there, methyl is there. Now you start walking in a clockwise direction and anti-clockwise. So one step you go ahead, you meet 2 degree. Here you go one step, you meet 2 degree. Again you move, you get 2 degree. Here you move, you get 3 degree. So in the second step, once you were moving clockwise and once you were moving anti-clockwise, you saw that the second step there was a 2 degree carbon, and in anti-clockwise the second step you got 3 degree carbon. So from there you got a difference. The two routes are not same, and therefore the two groups clockwise, anti-clockwise are different, and again this carbon is going to be chiral in nature, because already methyl is different from hydrogen, and you have found that these two routes, this and these two routes are different, and since these are different, all the 4 groups are different, so you have 2 chiral carbons in this compound. So you have 2 chiral carbons in this compound. Now in a similar manner, now we are going to judge about the compound number D. Once you start doing the D, first I will start from here. You got 2 hydrogens which are same, so it cannot be chiral. Now you come to this carbon, this is ethyl group, this is hydrogen, and about these two you start taking a walk in anti-clockwise and in clockwise direction. You move one position, and here you understand you have got 2 degree carbon. You move in this direction, you find that you have got 3 degree carbon, because this carbon is attached with 3 carbons directly. So the first step you took in clockwise gave you 2 degree, anti-clockwise, first step you took in anti-clockwise gave you 2 degree, first step you took clockwise gave you 3 degree, the first step itself gave a point of difference, so this should be a chiral carbon. Similarly you can see for the others also. So for others also we will do in a similar manner. So let us try to see for others also. Now if you take up this carbon, this is methyl, this is hydrogen, and once you start in anti-clockwise, the first carbon you meet is a 3 degree. You go here clockwise, the first carbon you meet is quaternary. Why it is quaternary? Because this carbon is attached with 4 carbons directly. 1, 2, here 3 and here 4. So this carbon is quaternary because it is directly attached with 4 carbon. However, this carbon, once you were moving in a anti-clockwise direction, this carbon was directly attached with 3 carbons, so it was a 3 degree carbon. So you understand, the first step you took created a difference, and therefore the two paths must be different in nature. So again, this is going to be chiral in nature. In a similar manner, we will keep on moving, and now let us see the next carbon. So once you try to see this particular carbon, so here you understand a methyl group is there, here you understand an ethyl group is there. Here one step you took in this direction, the clockwise, you met a 2 degree carbon because it is directly attached with 2 carbon. In the anti-clockwise direction you moved, you found this is a 3 degree because this is attached with 3 carbons directly. So again, one step you took, here you found 2 degree, there you found 3 degree, again a point of difference came. So this must be a chiral center, again a chiral center. Okay, now once we move ahead to find others also, let us try to see. You understand, if we try to see about this, again the answer is no. Why? Because there are 2 hydrogens, so 2 groups you found same, so it cannot be chiral. Now again moving one step ahead, this carbon, so here you understand one is hydrogen, one is methyl, and once you try to move in the clockwise and anti-clockwise, you find that this is a 2 degree, this is also 2 degree. You moved one position ahead, this is a 3 degree carbon, you moved one position ahead and you found that this is a quaternary carbon. This is 3 degree because this is directly attached with 3 carbon. This is quaternary because this is directly attached with 4 carbon, 1, 2, 3 and 4. So this carbon gave a difference in the second step. In the second step, the clockwise you found a 3 degree carbon, but anti-clockwise you found a quaternary 4 degree carbon, and there created a difference. So again you have this as a chiral center. Okay, so altogether if you combine all these things, so you find that it all together has 4 chiral centers. So that is how you have to think it in a very fundamental, in a very conceptual manner, that the carbons must be attached with 4 different groups, and while the carbon is a part of a cycle, then the cyclic paths you have to take clockwise and anti-clockwise direction, and there you have to see the point of difference. If at all there is a point of difference which you come across, those 2 groups must be different in nature. However, if you find that ditto you moved in the same environment, both the directions, both the 2 groups are not different but same, so that carbon cannot be a chiral carbon. Okay, so if we now try to count all the chiral carbons, so here we found that this was a chiral carbon, 1. Here you found that this is one of the chiral carbon, again you found this is a chiral carbon, again you found this is a chiral carbon, and again you found this is a chiral carbon. So altogether here you get 4 number. Here you found that this is a chiral carbon and this is a chiral carbon, here the numbers are 2, and in this you found that this is a chiral carbon, this is the chiral carbon, this is the chiral carbon, and this is the chiral carbon. Again the total numbers are 4. So altogether if you count, then the answer is 1 plus 4 plus 4 plus 2. So the answer is 11. 5, 4, 9 and 2, 11. So the final answer is going to be 11. So this problem was very fundamental, basic starting of stereoisomerism. Here I tried to explain you what is the meaning of chiral carbon and the various names you can take for a chiral carbon. How the carbon attached with 4 different groups is called as chiral carbon, and how if it is a part of a cycle, you have to judge whether the 4 groups are same or different, and everything was covered in this very fundamental and basic question. So I hope you all must have got the finer details regarding the chiral carbon. So in the future videos we are going to now expand our vision and keep including different topics, and in this manner we are gradually going to go in the core of the topic. Till then, keep watching my videos and keep appreciating also. Until then, take a good care of your health and happiness. Thank you very much.